Can you see the screen now?
Yes, it's just going to be.
Can you see the screen?
No. Yes, I can see it now. It's probably working now.
All right.
Okay, so good luck. Stage is all yours now.
Okay, so as mentioned, my name is Tom, and I worked in a tech company for about 11 years, doing a lot of technology implementations with using multiple types of technologies in the bottom, anything from traditional data warehousing, data analytics technologies, process automations, improvement, ERP, etc. I moved to the technology part of KPMG about 5 years ago, and I think one of the major changes from when you're approaching something from a pure technology perspective towards having this value-based approach to it is not only looking at what the technology is and what can it do, but basically approaching it from the side of the use cases and the business needs. So today I'll talk briefly about digital twins. Digital twin is, well, let's say it's complicated, right? Because these days nobody really agrees on what digital twins is. There's a lot of people talking about it, and basically these days anyone who has an advanced dashboard or something like that is going to tell you that they're working on a digital twin, which is not true, but it's difficult to say that it's not also correct when there's no agreed definition in this space. So yeah, what's a digital twin? And again, this is in my definition of it, where you have to look at the different type of capabilities that you have to mix into it. And I would say at least there has to be 5 type of capabilities involved before you can really start talking about calling it a digital twin at least. And then I'll go a little bit to the value aspect later. So number one, and this is I think the most basic part, is you have the capability to visualize. Since you're representing something physical, whether or not that's a generator or it's a production unit or it's a windmill or whatever it is, you have to have the capability to visualize what's going on with that asset or that process or whatever physical entity it is that you're twinning. Second of all, you need to have contact to the device itself real time, because you're trying to represent what's going on with the device currently and at a high level of granularity. You also have to have this real-time connection, and this is where, of course, IoT also or other types of data capture comes into play. Thirdly, you would need to have some way of communicating back to the actual physical assets. Doesn't have to be a physical asset, of course, it could be a process. But anyways, if you're going to control and manipulate and improve the actual physical item, you need to have two-way communication set into place. 4, normally you would want to use the twin in an application which deals with both real-time monitoring, alerts, or the ability to analyze outputs that coming from the actual assets. So you would need some capability in order to do that. So again, let's say if you're monitoring a power generator, you would need to have some way of actually getting alerts or getting predictions that can tell you that, well, there's an anomaly here based on what we think it should be behaving versus what it's actually doing. And number 5, and it's quickly related to number 4, is simulation and optimization capacity. So part of the use cases that's coming from the twin aspects are related to taking that assets and simulating what will happen under a set of conditions, or how do we actually optimize the output of it. So again, this is sort of our model. There's multiple other models in place, but they all sort of play along with these 5 integrated elements in how you can use it. And as I mentioned, because there is no standard, you will also hear people talking about twins in different types of capability. I think also it's important is that the digital twin capability is not something that you buy. It's not an off-the-shelf product. I would rather say it's sort of an ambition. It's something you develop over the time. You might have to use multiple system components. It will require maybe multiple platforms or at least multiple components to be built on the same platform. And you can develop these 5 capabilities over time to support different types of use cases. So how do you sort of align that value and those use cases with what you're trying to achieve? Well, we're going to just take a high-level view first in order to look at how is the platform and digital twin thinking linked to whatever you're trying to achieve on the business side. And the problem with sort of a pure technology-driven approach to this is that you will very quickly start building the platform, but you're not necessarily delivering and realizing the most valuable use cases. And the reason why that happens is because, well, a lot of the times when it's new emerging technology like this, the initiatives are quite commonly driven by the IT or technology side in some way. And the problem with that is that, you know, I'm a technology person myself. So the problem is you get very excited with a lot of these early technologies, but you're not really approaching it from the sides of the business. You're approaching it from, this is our platform, this is digital twins, just to use that example. It's very exciting, it's new, we have all these new solution components, and we wanna try it out, right? But you're not necessarily delivering actually what the business needs. And if you look at a platform and components to what's integrated into something like a digital twin, it's very easy to start on the wrong side of things and to pick use cases that are not really valuable because you're too occupied with experimenting with the technology itself. I'm not saying experimentation is bad. I'm just saying that you have to approach it from a different angle, and you have to balance the value and the use cases that it's coming on one side from the needs of the business versus your data strategy and how that links into what your digital twin is going to help you realize, right? Now, there's, continuing on that note, there's like 2 sides to the value equation, right? One is the benefits that you could look to have, basically what you put on as you get more mature, your use cases will get also more advanced, and you will also get more value to it. Now, getting more value to it is basically then linked back to the fact that you're focusing on the area that the business really needs to deliver on. The other side of this coin, and this is the investment side, is that you cannot start, if you think of it as a set of stairs, right, in terms of maturity. Let's say you just started with your asset and you got some basic historical data, right? That's basically level 0. You're nowhere at this point, but you're starting on your journey. You cannot put a use case for the next 6 months on what's called, would be very cognitive, very advanced using optimization and simulation, because you haven't really gotten to grasp of the fundamentals of things. So what a lot of organizations do is they draw up this roadmap, and it looks very nice, but the problem is it's only a roadmap, or it's not realistic in terms of the level of maturity. So when you start targeting use cases, you also have to look at, okay, where am I on this journey? what capabilities are we integrated in the twin currently, and what use cases are realistic to achieve. Now, that has to be balanced on the other side of the investment portfolio. So if you're missing capabilities in, let's say, your data platform, or you don't have simulation software, or you don't have real-time streaming capabilities, etc., you would need to look at, well, in order to realize these use cases, we need to do investments in both process changes, platform changes, or other types of technical capabilities, right? And they need to be looked at in balance, because the problems, either then you're aiming too high in terms of the use cases you're going after, so you won't be able to realize them, or two, you're able to realize the use case, but actually the money that's going to be spent to it is going to outweigh the benefits that you're getting, right? So there has to be a balance in terms of the value you get from your use cases and the capabilities that you're investing in order to build your digital twin. And again, this is a journey, so you can expect it to evolve over time. And as you become more and more mature, you can target more and more valuable use cases. There's also a lot of challenges when you start drilling down into these different types of use cases, right? So let's say you decided you're going to focus on the efficiency aspect of it, predictive maintenance, and assets where we're trying to optimize. How do we detect anomalies? How do we optimize the level of frequency where we do work orders on that asset, and how do we monitor its current real-time status? This is pretty basic stuff in terms of the efficiency. So you decided, okay, look, that's the use case. It's going to provide us X amount of money, better uptime, better, quicker time to change equipment, etc. But then you need to connect it back to the processes and your work orders. Because a lot of times what happens is that we are too preoccupied with basically trying to get the data, but not good enough integrating it. So integrating the data into our decisions, our actions, or actually having that insight into the work process itself can sometimes be, or most of the time, actually, that's the biggest challenge. I'm not saying that, the technology could be complicated, but it's just because of the platform capabilities are pretty much, developed by someone else. It's the application into your processes as an organization, which is going to be sort of the make or break for whether or not you succeed or not. So I'll give an example, right? There was this company, we don't have to go into details of who, but they had basically started with monitoring windmills. And they were going to monitor the windmills in order to check if the blades, which can have corrosion or otherwise have anomalies on them, to get early warning prevention, you're monitoring the windmills and then you're using visual images. Now, in order to get the visual images in this case, because they're windmills that aren't on land, they're quite far off the sea, they need to have drones to do the inspection. And on the drones, they can do the footage, and then you can do image interpretation on what the drone is receiving. Now, from a technology perspective, this is, all quite cool at this point, right? So you have an asset, a windmill, which is in itself, something with a lot of technology in it. You have drones with video footage. You have machine learning algorithms that's interpreting all of this data. And then you had an algorithm that could do anomaly detection and early warnings and prediction. And we're talking to all these data scientists that I have on my team, and they were really, really excited by it. And as a technologist at heart, I was also getting excited. So it's like, yeah, this seems like a good idea. However, then you really start thinking about it, right? So we started asking some very basic question. So it turns out, in order to check the blades, they can't be rotating because they rotate too quick. So the video isn't actually able to capture it enough. So the blades have to be still. And also, since you're capturing the video via these drones, that means you have to have a drone out there while the blades are not rotating. So these windmills are, as you know, with these huge windmills, at least in Norway, they're not placed really in where people live. So this is middle of nowhere, and there's no monitor person or anyone else living there. And because there's also regulation on the drones, you can't have a remote operated drones without having a certificate and a person actually looking at the drones. So when you piece this together, it means that, okay, the windmill has to be standing still, so the blades. There's no guy or girl that's living there, and he has to operate the drones. And when the drone flies out, of course, it can't be windy conditions. So then we started talking to him, well, how are you actually going to tie this back to the work orders and the inspections? Because are you trying to wait until there's no wind before you send someone out there? That person has to travel quite a long way. So anyways, he would have to, he would have to travel out by, quite a few distances in order to look there. Or are you going to stop the windmill blades from turning just so you can get an inspection photo? So they managed again to figure it out, but it turned out to be, it was a totally different solution. But my point is that the use case that you're realizing was actually very valuable in terms of doing this anomaly detection. The problem is they hadn't thought out how the inspection process and how all of these data was actually going to be used application-wise. So there wasn't anything wrong with the data capture. There wasn't anything wrong with the machine learning algorithms. The problem was that it wasn't all put together in a way that makes you actually change your work orders and the processes that you have behind, right? And I think this is quite a common challenge that we see in organizations, that they're quite good at either the strategy part or the data and platform part, but very few are good at integrating it in a proper way. So a little notice with regards to platforms, right? So as you're trying to build these data platforms in order to support your TRIM project, you will find that you would need multiple components, right? And what's going on currently in the data platform space is that a lot of organizations are basically seeing that the way they built their current capabilities are not really that scalable. Meaning that the typical way we approach it when you're building the platform, right, is that you have a multiple set of sources. It could be from your OT side, operational equipment. It could be from the IT side. It could be from your process space, etc., etc. The problem is you have this central engineering team, data engineers, and they're always, 100% maxed out in capacity, because you have all of these business needs and you also have all of these data engineering needs. And then they're not intact in terms of the business need is always increasing, and you have all these source systems over here, but in the middle you have this huge bottleneck, which is your data engineering team. And you can't just keep hiring data engineer, because that approach doesn't really scale. But also you can't just tell the business side to, well, go get the data yourself, because you probably don't have sort of that type of foundation over on your software engineering side. So there's a bigger shift now to something that's called data mesh, which is basically more of an organizational change than it is a technology change, and treating data as a product, getting data from the source systems more transformed. So basically what you're doing is you're putting some of the engineering work and putting it on the software engineers, currently software engineers are really treating data as this byproduct that they're getting out of them software engineering development project. What we want to do is get this data product to have as much priority on your backlog as any type of other functional application or service that you're building, right? So you really have to elevate your thinking with regards to data and how you treat it as a product in the organization. Now, if you start doing that, there's a couple of other things you have to also take care of in this. That means, first of all, the business side has to take more responsibility. Right? Currently, there's you could hear a lot of people on the business side saying that, well, we have poor data quality, so we have an IT problem. That's really not true. Poor data quality is not an IT problem, it's a business problem, right? So as in your different domains, you have to take greater accountability for the data that you're delivering, and you have to take ownership of the data products that you have under your domain. So your domain could be, HR, it could be customer service, it could be your production units, it could be a whole bunch of things. The point is that you are basically taking the data product thinking and putting it closer to the domains and the business. The other thing you have to do is you have to have a framework and standards in order to support these different units in a different ways. So yes, there will still be a distributed data platform, but you still need a central team that can help, enable that team and put these components as part of the platform in place. So that's your data catalog, that's your data discovery tool, probably will be a data lake component and somewhere. And we're not removing the analytics team. We are basically saying that, look, you are different nodes on this data mesh, and the analytical team, which is maybe operating, for example, your traditional data warehouse or other units, is just one node on that data mesh. So that means that you are basically still scaling out a platform in your enterprise, but you're doing it in a different way instead of having this central engineering team. In order to succeed with it, you still need to have standards for data exchange. So you're probably not going to have 20 different ways that you can, exchange data from your source systems. But you'll probably also not have one. So you probably end up with something like a handful where you basically say, look, this is how we support data exchange. This is the standards that we will be supporting. This is the way on the platform on where we deliver data. And then you can look at it from a way of, well, we're supporting a series of formats, but we're not supporting everything, right? And then you have to have in terms of data ownerships and control, you need to have requirements in order to how do you protect access to this data, right? So security, of course, becomes a huge part of this because you can't let anyone out. Well, you have to have access controls in order to make sure that the data products are available to the right types of personnel in this manner. Once you start integrated into the process, and you will see this is where a lot of these challenges come up, you'll see that you typically start with this level 1 application of, well, we have a human and he's putting data in some sort of digital surface, some sort of digital application, and then we can at least start to capture it. Once you start moving up, the second thing is you'll most likely start automating based on a given set of rules as you're capturing data. And then you'll find that you start shifting responsibility between the human and what's doing automated, because you're feeding back insights and information to the human that's actually working in that process. Once you go to level 4, level 5, you will see that you start shifting responsibility in terms of the system, and the process is actually giving you recommendations and what to do. And level 5 is where the process is then highly automated. There's a lot of data that's being exchanged. There's also continuous set of predictions in terms of what are we doing, what are we operating. But then you'll find that you also have to go back into level 4 in terms of have a human in the loop in these types of controls. It's basically like the same logic when you have if you have a car that's a modern, like a Tesla these days, which is trying to move upwards on the ladder in terms of autonomous operations. But you also find that you have to go back to having human in the loops as you move on that journey, right? You'll also see what as you're trying to shift to this area, you are not going to do this as one giant step from where you currently are. It's most likely going to be this process where you're shifting gradually from having a central data platform and just delivering raw data into that, moving into simple data products, which are then more transformed at the source systems. So once they're delivered on the platform, they're easier for others to take usage of. Then you'll find that maybe you start delivering data products externally because you both have internal and external users. And then at the end, you might end up with a more distributed model where basically the different teams and different product owners are offering their own products at a higher set of scale and also more decentralized. From a platform perspective, right, you have to look at this central platform as a set of capabilities, and there still has to be a central team that needs to manage that platform. So they will be responsible for putting in place the technology components, making sure that you select the right type of technology that's there on your platform. You probably already have a lot of it in place already. So what you'll see is that you're expanding on that, but most importantly, you're shifting responsibilities upstream in your data extraction process. So instead of the sort of traditional extract, transform, load type of thinking, you'll be doing a lot of the transformation part earlier in the process and closer to the source systems. You also find that this is your journey in the organization could be quite easy characterized as you start initially with having your data in silos, right? And then you start building your data platform that takes in these basic type of reporting needs. Once you're there, most likely you'll switch to more of a hub type thinking, where you start building more advanced analytics and the ability to do diagnostics. You'll also be start supporting a larger set of use cases. And then your end state is sort of a hybrid of this, where you still have that foundation at the bottom, but you're delivering a set of highly differentiated products, processes that's going to be supported. And you have to do the data exchange there using modern APIs, analytical services, or other type of common components, because in order to succeed with the integration, you can't just rely on it on using traditional or more older method, right? Plenty of organizations have these data wares that are just sitting there. They have a bunch of reports, but maybe not too much usage of it or too much value, right? In terms of how you're getting it into the actual process. Some challenges in as you progress towards this journey. There's a whole series of them, but we tend to group them into use case problems, capacity problems, or sort of process integration problems. So typically in terms of the use cases is that you might end up in this valley that once people start using data for monitoring or reporting or analytics, etc., you just have these huge needs and huge backlog of use cases that people want to be solved. But the value of it might be, in a lot of cases, negligible. There's so much business need in order to deliver and use this data. A lot of organizations really, can't sort of integrate it or actually properly use it. So there's a lot of reports and a lot of fancy dashboards being built, but a lot of the times you're missing this actual integration, which is where the value actually comes into play. The second one is the capacity problems, which is a lot of times either driven by IT builds the platform first, and then the use cases will come, or the platform capability is an issue. Security is, of course, something that's predominantly not being handled correctly in a lot of organizations, and privacy issues can, of course, come in here. Capacity also can be that you're over-reliant on external ones. And the last category, and also the last point that I'll make before I finish off is, and I've said this earlier as well, is the process integration part. You're not able to deploy algorithms. You're not able to use actual decisions based on the data that you're providing. And then overall, you're not changing the way you're working. You're just trying to put a lot of data or insight out there, but not actually connecting it end to end. So yeah, to finish off, the digital twin space and data product space is sort of coming into play from both of their angles. Just be careful on your journey as how you're approaching it. Start with valuable use cases first. Focus on integrating it into your work processes, and then build capability as you mature along the way. I'll stop sharing now.